Just wanted to hop in and say best of luck. I am not lurking in the shadows actively right now, but best of luck on
the video.
I'm going to try to not hire the cinematographer from Blair Witch Project to do the lighting in this room anymore, but I just wanted to hop in and say best of luck, and I'll be here if you need anything.
All righty. Thanks, sir.
Okay, it's 10 o'clock. Good morning, good afternoon, good evening, wherever you are joining from around the world. Welcome to GroupBy 2021. This is the track 2 American version. There's another one will be in Europe. And we have our Andy's with me to help me moderate this session. And Peter is our first speaker. And Peter will be talking about lift and shift, take your tuning skills to Azure. And I will hand over this to Peter. But before I do that, housekeeping rule, if you have any question for Peter, please put those in the chat. Andy and I will be keeping an eye on the chat. And Peter have scheduled breaks in between. Peter also has some time reserved at the end to answer those. But if there's some immediate, he will stop and answer those if it's relevant. And then we'll have a little bit of break before the next sessions for you to, grab a drink and switch over to a different track in case if you want to move to track 1. So Peter, take it away.
Thank you, Tobe. All right. So a couple of housekeeping items before we get to my content. GroupBy does have a code of conduct, and there's an expectation that it will be adhered to. Basically, don't harass anybody, be nice to everybody. And if you have opinions that are contrary to being nice to people, keep them to yourselves. Don't bring them here. That's the very, very short version of their quick version. Also, conferences like this would not be possible without sponsors. So I'd really like to acknowledge Redgate, SolarWinds, SQL Solutions Group, and Minionware for their assistance in helping this GroupBy conference take place. All righty. Let's talk about lift and shift. Take your tuning skills to Azure. Because we all know that the cloud is a thing. And I drink the blue Kool-Aid, so we're talking about Azure. A little about me, then we'll get into what the session's about. I'm a SQL Server database administrator at Chipotle Mexican Grill. The answer to that question you're wondering is yes. I'm an intentionally accidental DBA, meaning my career path looks exactly like the accidental DBA, except I'm just goofy enough to have made the decision to do it on purpose. You can see there my over 25 years of IT experience outside of the DBA realm. I am the president of CBus Data, the user group here in the Columbus, Ohio area. When we had them and when we have them again, if we have them again, opinions aside there, I co-organized SQL Saturday Columbus. We may come back as Data Saturday Columbus. Who knows? We intend to have events again when the time is safe for that. You can find me on Twitter at pshore73. You can email me at pshore73@outlook.com. And the duck down on the bottom there is an indicator that I am finishing up my run in the class of in the 2020-2021 IDERA ACE class. It's a program IDERA had put in place to help certain folks who have been selected for the program to increase their exposure in the community. We're going to talk about introducing some Azure. We're going to take a little bit of time just to give a brief overview. I want to do a little bit of level setting on what tuning is from my perspective. because it kind of lends itself to the rest of the session. I want everybody to be aware that while we are going to talk about the lift and shift, what's the same, what's similar, what's different, it's not necessarily going to be in that specific order. This is very much a survey course or survey session, a 100 level session around what is the same. That is our primary focus. We want you to be comfortable with all those skills you've built up, that they're going to work in Azure, but we also want to highlight some of the things that are similar and slightly different, so that you can be effective in your tuning and be less apprehensive perhaps about Azure. I know I've certainly talked to some DBAs who have some concerns about cloud and how it affects their role. So a little bit of Azure. Cloud generally breaks down to 3 service classes. Infrastructure as a service, IaaS, is virtual machines. It in reality is just like the virtual machines you have on-prem right now. In fact, in Azure, it's an upscaled version of Hyper-V that runs the virtual machine environment. And it can replace all of your server-based infrastructure. Careful to say server-based because obviously it can't replace your networking because you still need connectivity. The vendor, Microsoft in this case, manages the hardware and the hypervisor, which is Hyper-V. You manage, as the customer, creation and deployment of the VMs, install and configuration of any software. Now, many vendors, including Microsoft for SQL Server, have VMs that are pre-built in the marketplace, and you can simply deploy those. You should note that the SQL Server VM also comes with analysis services and integration services installed. You're going to want to remove those. If you need an older version or a specific older patch version of the current major release, you'll need to install that yourself. Speaking of patching, you are in fact responsible for patching OS and applications, of which SQL Server is one. You are responsible for recovery, which means backups, testing them, and then implementing your recovery scenario. You're also responsible for making sure HA is set up and configured. You're also responsible for access control. Now, Microsoft will handle access control and patching and recoverability on the pieces they manage in IaaS, just the hardware and the hypervisor, as I said. Otherwise, it's you. Now, platform as a service takes some of the work from you. While it replaces most back-end infrastructure, anything that needs to be installed and run and have access to the operating system doesn't work here. SQL Server has been retooled, not really retooled. SQL Server runs and doesn't need that kind of access to the operating system where you're involved, at least, to make so it runs fine. Microsoft, the vendor again, manages all of those things: the hardware, the hypervisor, the install and config, the backups, and the patching. In fact, if you really want to get your nerd on, there is a great white paper about how Microsoft streams and slips the patches into Azure SQL DB. Completely irrelevant to what we're talking about today, but it is really a good deep nerd dive if you're interested. As the customer, you're responsible for configuration, particularly of your application, and of course your own database design. Database design is still relevant from a performance perspective. You're responsible for your database deployments, getting the database and then eventually the data to where you need it to be. And of course, still access control. Software as a service. This is your productivity software. This is Office 365, SharePoint 365, Exchange 365, Power BI. There is no SQL Server component outside of Power BI, if you want to call it that, in this tier of software or of service. Microsoft does everything except storage access, which means you need to provide a place. Microsoft would like that to be OneDrive to store the Excel files and the Word documents, the PowerPoint presentations and all of those things. And you are still, in fact, responsible for access control. In case it's not obvious, when I say you, I don't necessarily mean you. I mean you. Someone at your company, a group of folks at your company, there's a team that's going to manage some of these things. Some of them will be your team. Maybe you wear multiple of those hats, in which case it is, in fact, you. Otherwise, I'm talking about the generic you. We need to talk about the cost piece of Azure just a minute. From an on-premises perspective, you're talking about capital expenditure, CapEx, and you're really paying today for resources of today and tomorrow. You need to have the resources to support those 5 big days of burrito sales that you have this year and next year and next year and next year until that hardware gets replaced. You need somewhat accurate forecasting then for compute and storage needs. The cloud cost is an operational expenditure. You're paying today for the resources of today. Okay, really it's monthly. It's not today. You're only writing a check or doing a transfer monthly. And those compute and storage resources are elastic, which means we can change them on the fly. Of course, that means the bill is elastic too. It changes along with those. But we can be much more effective in provisioning resources for our workloads and what we need. It also means that if you want to take the time to figure it out, you could, in theory, tell that developer who wrote that really bad query that, hey, this query costs, 3/100ths of a cent every time it gets run, and it gets run 25,000 times a day. You can do the math, and now you can talk in financial terms how much a query costs and prioritize some of your tuning based on that, not just resource utilization. The pizza is a service slide. I'd love to give credit for this, but it has been out so long. I'm not sure who originally gave this slide out. It is not a perfect analog. The key takeaway here is the things that are in blue are managed by you. The things in green managed by the vendor. As we start in traditional on-prem on the left and move right to software as a service, we can see how the vendor manages more and we manage less. However, from a SQL perspective, the things that are in that less are extremely important from a day-to-day operational perspective, because a lot of it is actually tuning. This map, accurate as of a few weeks ago. Always important when you're talking about Azure or any cloud service to define when you got the information, because it changes. The bright spots, which are, I think, officially cyan in color, are current Azure regions. That's the group of data centers. There are some lighter spots on the map that are proposed regions. The point of showing this is just the idea that, hey, if you're sitting in place X, you may or may not be close to where your data is actually stored. And that does play a part in perceived performance. Microsoft despite all their attempts to not be, is still bound by the laws of physics, even if they try to say that 186,000 miles per second is too slow. Tuning. This is my soundbite definition: the scientific art form balancing minimal query duration and efficient resource utilization. All right, it's not science like a lab. There's no beakers, it's not chemistry, it's not physics. But what it is iterative with plenty of testing, the thought out process. But the thought is where that art comes in, which is not Ella Fitzgerald. It's not Martha Graham. It's not Toni Morrison. It's not Pablo Picasso. Rather, it's art from we need to be creative, nonlinear, dare I say, out of the box thinking perspective. Because sometimes we need to make some value judgments around what makes sense. Can I afford a little increase in CPU to really drop reads? The answer to that is almost always yes. What are my other ways to do this? Why isn't this working? How can I make it better? All right, any questions so far?
No, Peter, no questions so far. So everyone, if you want to ask any question, please put in the Q&A panel. Andy and I are monitoring that. And Peter has breaks in between that he can answer those questions, even if you have a comment. So I have a comment, Peter.
Yes, sir.
When you talked about IaaS, and you might be touching it later on if that's so, you can ignore it. IaaS extension agent will take care of a couple of things that you mentioned, right? Like backups and a couple of things that if you choose to use that, just making a point.
Thank you, Tayo. I mentioned that to myself both of the times that I ran through that slide earlier, and then I forgot when I did it live. Yes, there is in the Azure VMs something called the SQL IaaS extension. As Tayo said, it makes the VMs a little more platform as a service-y. In your experience, it will patch OS, it will patch SQL Server. It can help you with the automation and backups without moving completely to the PaaS solution. Yes, it still has the challenge of not being perfectly able to be automated from an availability group perspective, but really nothing is doing that perfectly at this point. So thank you again, Tayo, for bringing that up. It completely slipped my mind as I was talking.
No worries, thank you. Yeah, no questions, so you can continue.
Cool. So performance tuning and query tuning. I know a lot of folks use those completely interchangeably. You're not wrong in doing that, but it's also not completely accurate because they're not quite the same thing. Query tuning is really a subset, a very large subset most of the time, of performance tuning. And if we were to look at that in terms of a Venn diagram, we would not have an overlap. What we would really have is concentric circles. Now, I drew the concentric circles. Does this mean this is what I think the percentage of the ratio of performance tuning to query tuning in that whole bucket is? No. I was not attempting to do anything from an accuracy perspective. This is a conceptual drawing to paint the picture that query tuning is a very large subset of performance tuning. So what do I mean? Performance tuning is holistic. Performance tuning talks about the things that are at the instance level, the query level, and outside of SQL Server. By outside of SQL Server, we're talking about the underlying OS, the hypervisor, the hardware, the storage, the network. All of those other things where we're having to take evidence and talk to other teams. And maintenance, in my opinion, fits into performance tuning. And not simply the when are we going to run CheckDB to not use the resources. Also, things like when do we run index maintenance and stats updates? What sample size do we use for stats updates? How tactical do we get in our stats updates? Do we just update them all? Do we only update a subset of the ones that are being used in queries? All of that plays into performance tuning. Yes, you may not have to performance tune as often, but it, like query tuning, is also not necessarily done the first time you do it. Query tuning is exactly what you think query tuning is. You're looking at the code, whether it be an individual query from an ad hoc query or an ORM or a procedure, and it is specific to that one iteration. Now, it is highly likely that when you make that really ugly query better, everything will benefit, but it's still not holistic from a work effort perspective. And of course, we're looking at data types. I mentioned this because I have worked in too many environments with poorly configured ORMs, and implicit conversions are one of the banes of my existence, right along with key lookups. We're looking at joins and predicates, and we're trying to encourage our developers to return minimum viable results. Don't bring back any more data than you need. And that is really how I see the difference between performance tuning and query tuning. So there's tuning in IaaS, and there are some critical differences, particularly for performance tuning, that places outside of the query and outside of SQL Server in IaaS that change the way we can do things. We don't have access to the hardware layer. So we can't call somebody and say, hey, this version of the driver, this version of the firmware is going to make my life better. We just can't do that. We don't have access to the virtualization layer, so we can't put in, configurations that make us have an easier time at the virtualization layer. While it is important on the virtualization side on-prem to make sure we're deploying to workload rather than server size, it's even more important in the cloud, and therefore different than what we have on-prem. Because, as we talked about earlier, the bill comes every month. With the ability to auto scale and scale up, we can live a little closer to our needs today and move up as we need to, rather than having to project and buy ahead, as I mentioned earlier. I bring storage, pardon me. I bring storage forward here, even though we don't have access to storage, because there are a couple of ways that managing storage is different in the cloud, and they're important. We have multiple disk types. Three really that I want to mention. There's a local SSD that is ephemeral. It's temporary storage that Microsoft's own best practices suggest putting tempdb on. Because tempdb doesn't need to be recovered, and it can be recreated every time the instance starts up. And this is one of the things that IaaS extension that Teo reminded me of helps to manage. There are premium disks and there are ultra disks. These are disk classes, and they really talk about this difference in speed of the disks. And when I say speed of disks, you should really be hearing how much these disks cost. It also has to do with the IOPS, the input output operations per second, reads and writes per second of the disk. And there, when you start to dig into that a little bit, you can find that depending on how you configure things, you get some better options. If you do a disk pool of a lower IOPS, because the disks then aggregate them. In a pool, you can aggregate all of the IOPS for that particular set of disks, and you get the benefit of all of that, which may save you some money over going to a bigger disk or an ultra disk. Disk caching is a thing in Azure for the data files only. You want your data files to be set for read-only caching. And that caching actually goes to that ephemeral storage. So you have to balance some of that space with TempDB. Transaction logs should not have any caching enabled because testing has found that there can be issues if you start to cache transaction log. One of the things you have to be aware of, because on-prem, our disks do have IOPS limits. No matter how good the storage you have is, there are physical limits. One of the things we don't necessarily deal with as much on-prem is a hard limit per VM for virtual machine for maximum IOPS. And it's not just the operations, it's also the data size per second. Frequently, the virtual machines limits are lower than the disk limits because Microsoft has configured things to really minimize your blast radius, minimize you being a noisy neighbor or you having a noisy neighbor that affects your performance. That IOPS thing is a problem for me right now in one of my machines. Then we're working on the coding of that to try and reduce IO. Don't ask me about that one. That's just an ugly mess. All right, now we've talked about those critical differences. Any questions about those differences?
Nothing in the Q&A panel. So everyone, a reminder again, if you have any questions, comments, please put it in the Q&A.
Yep. So I should give you the warning that as we get into some of these things that are familiar, you're going to see some repetition. And that's intentional because I'm trying to remind you that so much of what we're looking at is the same. Windows is in fact still Windows, whether you run it bare metal, virtualized on-prem, or virtualized in Azure. You still get the perf mount counters. You still have the configuration options that are there. Are there some best practices that are particular to Azure? Of course there are. But it is still Windows. It still behaves the same in all its lovely, wonderful, and quirky ways. Linux is Linux much the same way Windows is Windows. It still behaves like itself. I'm not a Linux admin. I can't tell you what that behavior is necessarily, but if you are running SQL on Linux, which is perfectly fine, works very well. I just happen not to be in my work environment doing that and haven't done any of it at home. Linux is still Linux and it works just fine. SQL Server is SQL Server. Everybody play along with me and say that again. SQL Server is SQL Server. It installs from the same ISO. Extended events are the same. The DMVs are the same. You query them just like you do on-prem. They provide you the same information about what's going on with your instance. Query store is the same, assuming, of course, that you're running SQL 2016 or higher. If you're not running 2016 or higher, and you move to that new version, the query store is new to you. Query plans are the same. And that's important because I know we all spend a lot of our performance tuning time and our query tuning time looking at query plans. Now, while I did say that SQL Server is SQL Server, and it is, the thing I should explicitly say is if you're looking version for version, if you both move to the cloud and upgrade your version of SQL Server, there may well be differences. That is not a cloud upgrade issue. Or a cloud upgrade change. Let's not call it an issue. That is, in fact, the same change you would see if you stayed on-prem. So let's not confuse the two. You're still going to take the same approach to tuning if you're an IaaS. Because the optimizer is still the optimizer. It still works the same. All those caveats that make plan creation difficult are still there. If you've got subqueries in your from statements, they're not going to get any better by moving to Azure as a VM. They're not going, if you're comparing in your predicate a create date to an last updated or last modified date in the same table, that's going to cause a problem for the query optimizer. If you're using not equal to in your where clause, that is going to cause a problem for your optimizer. The flip is true too. The things that we do to make the optimizer better and more effective for us still are the same. When we fix that not equal to, when we keep our statistics updated, when we realize after some testing that we really need to update these particular statistics at a full sample size, not a default sample size, so that we get a much better query plan. Those techniques still work. The tips and tricks that you've spent a career building about how to massage the optimizer still work. Of course, unless the optimizer itself changes if you're changing versions. That, again, is not a cloud change. That is just a SQL Server change. Some for the better, some for the worse. If you want to learn more about the cardinality estimator portion of that, I know Teo has a presentation on that that is available in various places. I'd suggest tracking that one down. Well, the query plans are the same. The optimizer is the same. T-SQL is still T-SQL. You're going to write code the same way. You're going to write with the same best practices. All the DML statements work the same. Inserts are still inserts. Deletes are still deletes. You still need to put a where clause on that delete so you don't delete everything. All the functions are still the same. Date add, get date, they still work like date add and get date. Some count, they all still work the same. They all require the GroupBy clause as well. And all the DDL statements work the same. So you're creating tables, creating indexes, creating databases, check DB, all of those things work the same. Yes, I'm saying a lot of the same. Why? Because it's the same, and we're trying to help you. I can't make you do anything. I'm trying to help you see that we can be comfortable. And this is the easiest leap to make, going from an on-prem VM to an Azure VM. Any questions on the IaaS piece?
There is a question from Survey.
Okay.
I'm going to read it. When we say SQL Server is not changing, does that mean database maintenance like rebuild index / update statistics would run for the same duration in Azure? Do we need to add more considerations with disk type / throughput for database rebuild index / update stats requirement with lift and shift model?
Fantastic question. And the answer is we always need to consider those maintenance tasks as part of our VM design, which includes what speed disks are we going to take and use. Moving to an Azure VM in IaaS does not change the need to look at those things. You're going to want to look at the IOPS, and that's where the disk pool sometimes comes into play, because you don't necessarily need a lot more space, but you need a lot more IOPS to manage some of those tools. I am always looking personally at what are the thresholds that we need from a fragmentation perspective. And there are debates and arguments, depending on who you're talking to, about what those thresholds should be, how you should approach that from a coding perspective and a design perspective. Physical design still matters, how you lay out the database, how you lay out the tables, how you lay out the files. All of that still matters and still impacts performance, just like it does on-prem. The question then becomes, what are the disks you're choosing? Microsoft by default recommends P30, which is as the smallest disk you should use. And then there are some resources at the end of this slide deck that talk specifically about VM storage and the VM checklist and the deploying the VM that you can dig further into for your specific situation. Did I sufficiently answer the questions, or a follow-up question to that?
I'm sure Surbi will type it if she has a follow-up question. For now, no. So
excellent. Platform as a service. Now we're losing a little more access to some of those underneath things that we would do as a performance tuner, those outside of the queries kind of things. Of course, we still don't have access to the hardware. We don't gain any access to the virtualization layer. We really don't have any access to pick what the storage is, other than at creation time, and the tier. And we can change the tier from basic to standard to premium to business critical. Of course, we can always change the sizing, because we need the space. If we have more data, we need the space to put it. Let's be honest, Microsoft is charging us for that space, so they're happy to let us buy more. Again, it's important to look at the workload size, not the server size, particularly as you move directly to a PaaS service, because it's not the same apples to apples comparison anyway. Take advantage of the auto scale. The easy scale up is a wonderful thing, because the reality is adding more CPU and more RAM is as simple as dragging a mouse or writing PowerShell, whichever you want to do it. We have no underlying OS access in platform as a service. Though we still can see performance counters in the DMVs. But if a follow-up comes in on that, please just let me know.
no, Surbi said you answered it well. Thanks.
Okay, cool. There are two specific Azure SQL services in platform as a service. There's Azure Managed Instance and Azure SQL DB. Azure Managed Instance is kind of the bridge. It's the bridge from on-prem or VMs to Azure SQL DB. Although at the same time I'm saying that, it's really its own standalone piece. You can live for a long time in Azure Managed Instance. The advantage to managed instances, you can have multiple user databases. So if you have an environment that has a high workload cross query or cross database querying environment, this may allow you to go to a true PaaS service. You still get agent. It's largely like traditional SQL Server in that you get agent, you have the cross database queries. You can still change some of the instance settings, max stop, cost threshold to parallelism. You can change TempDB. Honestly, when I saw you could change TempDB, I was a little bit surprised by that. Had you asked me before I confirmed, I would have said, no, you can't change TempDB, but you can. Should you change TempDB? Well, that's an entirely different question. My limited experience with managed instance, I haven't had to even ask that question of the instance yet. So that is a to be determined whether or not I will ever do it. You cannot change max memory. I touched on the common things that we change at an instance level. I didn't go, line by line through SP configure, obviously. Worth noting is database mail cannot send attachments from Azure Managed Instance. I find that to be worth noting because I know there have been times where I've been using database mail with jobs or certain situations to send me some additional information. If you were doing that and using attached files, you lose that ability. If you weren't doing that, now you have a trivia answer for some trivia question someday, sometime, somewhere. Let's talk about Azure SQL Database, and then we'll get back to some tuning specifics. Azure SQL Database is a single user database unless you're using elastic pools. Elastic pools are a pool of shared resources that are shared among multiple databases. The best situation for this is where the average utilization is fairly low, so you're not fighting over those resources. And there are occasional spikes in those single databases, hopefully that don't align with each other. You can also do some cross querying within that, although I haven't played with it enough to tell you what the caveats and limitations are of the cross querying. Azure SQL DB has less settings that can be changed. We can change the max stop as a database scope configuration, but we can't change the cost threshold to parallelism along with it. We also can't change max memory. We have no access to TempDB at all. We don't have any kind of database mail. We don't have agent. How do those, we talked a little bit about how mail plays into potential warnings and gathering additional information from a tuning perspective. Without agent, that means as we look at some maintenance items, we have to look to different ways to schedule tasks. We can schedule tasks, of course, in a VM and remote connect and run those stats updates, run those index defragmentation pieces. Or you can use a tool like Azure Automation and either write Azure CLI or Azure PowerShell to kick off those maintenance tasks. There are approaches to do it. You just don't have agent. All right. In managed instance, the DMVs behave as expected. You query them just like you would on premises or IaaS. They provide the same information, and they have three classes. The database-related management views, the execution-related management views, and the transaction-related management views. If you want to know other information, the DMVs do not supply them for you. Extended events are available, although you will need a storage account if you want to save to file. Query Store is available. We add things in more direct use here, like Azure Monitor for alerting and monitoring, which also means we get into log analytics and KQL. Just so happens Sayub also has a great session on that. Microsoft also digs deeper into automatic tuning here. Yes, intelligent query processing is a feature in SQL Server 2017 and 2019 on-prem, but it is a deeper and more fully fleshed out solution because of the telemetry they're able to gather in the cloud. A couple of things that you see out of intelligent query processing are adaptive join types. So SQL Server in the query plan puts an adaptive join, and that join mechanism changes depending on the data size going in. So we don't have that. So we reduce that challenge of join types that can cause us problems where it's not adaptive. We also get feedback on memory grants. SQL Server can add indexes. I know, we're all thinking DTA. And yes, I would want it to advise, and it will advise you of the indexes. I would want to advise and manage those myself. But then again, I'm a DBA. I'm a bit of a control freak. I don't want to give up that control. We can find those, of course, because query plans are the same. I mentioned there's some repetitiveness, right? The optimizer is still the same. Remember those caveats we talked about a couple minutes ago that make the plan more difficult to build for SQL Server? They still apply. Remember those approaches, those tried and true ways that we help SQL Server make better plans? We talked about them a couple minutes ago. They still apply. T-SQL is still T-SQL mostly. DML, data manipulation, works as designed. Functions work as designed. Many DDL statements work in the same manner. Some of them do not. I have a link that further explores that in the resources and acknowledgements section. Any questions on managed instance?
There's nothing, Peter,
Cool.
on the Q&A panel.
Azure SQL DB. Remember, this is largely a single database. DMVs behave as expected, although the names have changed slightly to protect the innocent or the guilty. You can see the example there. Bold, yellow type shows you what changes. SysDMOS wait stats become SysDMDB wait stats. So if you run a favorite query that looks at a DMV and it can't find that DMV, the first thing you should do is look up to see if the name has changed. First thing I would try is replace all of the OSs with DBs and see if that solves the problem. Otherwise, I would do some more research and look to see if the DMV still exists, if the name has been changed, or if you even need it. Interestingly enough, the perfmon DMV still exists. You can still see the perfmon counters in Azure SQL DB. You can't see them at the OS level because we can't see the OS, but we can see them from the DMV perspective. And generally, if the DMV exists, it provides the same information. It is scoped, of course, to the particular database, which is okay because we're really, for the most part, only looking at one database. Extended events are still available. So all of those extended events that you've built still work, except for the ones that are instance scoped. You need a storage account to save the data, but you can still do the ring buffer or directly to XML, which is directly to XML. And if you want to read XML for that, have fun. It's not my thing. Query store is available. I should say that in all the cases that I've mentioned, query store is available. You also have to make sure it's turned on and that your database is at a compatibility level that supports it. So it has to be on SQL Server 2016 compatibility level going forward. And you may say, well, I just brought my database in to Azure SQL DB. You should check the compatibility level, because if you've just been bringing it forward from a previous version and never intentionally changed it, you're probably still sitting at an older compatibility level. Before you do that in production, please test, because that's also going to change the cardinality estimator. And that may make things better and may make things worse, or it may be not a thing. That's why you need to test. We get Azure monitoring, we get the automatic tuning, and query plans are still the same because the optimizer is still the same. You've heard me talk through the caveats and remind you that the caveats, and I'm reminding you again that the caveats for making plans better and making plans worse, the tried and true techniques are still the same. As with managed instance, DML works the same. It works. You select, you insert, you update, you delete. The functions work the same. Many of the DDL statements work the same, just like managed instance. And this is Azure SQL DB. So one of the what you should be hearing from me at this point is a lot of what we see in Azure features, whether it's VMs in Azure, whether it's Azure Managed Instance or Azure SQL DB, is the same. Those query tuning skills, those performance tuning skills that you've spent a career honing, fine tuning, and getting really good at are still valid. They still work. We can still look in the DMVs for waiting tasks and high IO, high CPU, high frequency queries, long durations. Tools like SP Who is Active by Adam Mechanic, which I absolutely love, still work just like they're designed to work. We can still read query plans and find those high cost operators, the grant information, the index information, the missing indexes, the statistics, the key lookups, the implicit conversions. All that stuff is still there. In fact, I would state that, and I should have really stated it earlier, that indexes are kind of sort of the bridge from performance tuning to query tuning. It connects the two because we change indexes as we query tune to make them better, to cover, to be, to have those included columns, to make sure we're not having those key lookups. We look at the query plans and we review those missing index suggestions. I didn't say directly and blindly implement them, but it is absolutely a good idea to review them. Maybe we need to create a new index. Maybe we need to massage an existing index. Maybe we need to reorder the columns in an existing index or make it a new index with those reordered columns. Overlapping indexes are not always a good thing, and they're not always a bad thing. It depends on the workload. All of that we get out of the query plans and the DMVs. We can focus on the same things. All right. Any questions on my slides? We're going to run through a couple of very simple provers. As Penn Jillette would say, if you've ever watched the magic show Fool Us, you'd say there are some provers in the trick. For me, that means demos. So any questions?
No questions, Peter, at this time.
When I say questions, by the way, comments are good too.
Definitely, definitely. As I mentioned a few times, folks, questions, comments, anything.
All right. So I do need to, before I start any of that, I need to, on the screen, you can't see, kick off my workload.
We are seeing your management studio.
That's fine. I'm on the screen. You can't see that I'm kicking off some workload, just so there's some results. And of course, I tested this earlier and then I moved the command. Where did I put that typo?
So while Peter is
Sorry about that.
okay, go ahead.
All right. I'm not going to worry about that piece of the prover. And I will say that as I run these queries, I'll zoom in a little bit so you can read them. I'm not going to make you take an eye test. So what we have here is I'm connecting to a local SQL server that I'm running on this machine. I'm going to make sure I'm in the right database. And I'm going to run a query. We have the execution plan. All right. We see there's a missing index. It's got the impact cost, all the things you would expect to see. Now, query plans can be different. I'm in the right database this time. I'm not worried about the lack of a result set. Query plan is different, but we still have missing index hit. And this is in Azure SQL DB. I'm sorry, I don't have a managed instance. There's only so many credits to use in Azure.
So Peter, just to make it clear, the first one you ran was against on-premises SQL Server, and the second one is against the Azure.
Yeah, sorry to cut you off. It was the second one I ran was against Azure SQL DB, and this one is against an Azure SQL VM. So we can see we still get graphical plans with operators, missing index hints for the same query. Now, I forgot to change the details of the where clause, but to get a result set, but that's okay. We still get query plans. We still get query plans that look the same. They give us the same information. I won't bore you all with the XML. And just say we get the missing index. We get the we get the highlights, the tool tips that show us what we need. And I have a workload running. SP who is active comes back. This is my local machine. This is this is Azure SQL DB. That's the one that I was having the typo that I didn't troubleshoot very long. one thing you'll need to notice here is that SP who is active is actually in the user database. I was lazy and did not put it in its own schema. You may want to create a DBA schema to isolate things like who is active in some of your other tools. But, oops, what did I do? Apparently, I changed a connection on myself at some point. Oh, I see what I did. So there's, sorry, I forgot to change my tab group. So we can see that who is active brings back a result set in Azure SQL DB. So if you are a fan of Atom Mechanics stored proc, guess what? It still works. And here's my workload running against Azure SQL, my Azure SQL VM. I have 25 users, I have 25 rows. We can see we get a result set, not an error. And that is the key point here, that it still works. We're going to be a little more efficient and tricky going back down. We're going to start in my Azure VM. This is Paul Randall's Tell Me Where It Hurts query looking at wait stats. We get the result set that we would expect. We get wait stats. Notice this is sys DMOS wait stats. We do have some accumulated wait stats here because I was playing around with things earlier. This is Azure SQL DB, and notice we do have the DB wait stats, but we still have wait stats, which, as we all know, can help us with our troubleshooting and our performance tuning. And of course, our on-prem VM, we have wait stats there as well. I'm not concerned that they're not the same wait stats. I'm not concerned that I don't have the same number of wait stats. The prover in this is the idea that wait stats still work. We get results from that query and we can act on that as appropriate. Michael J. Swart has a fantastic tool set on his blog that shows he has queries for the top 20 most executed queries, the top 20 high CPU, the top 20 high IO, and the top 20 longest duration. Since IO is extremely expensive from a compute perspective, and to some degree in Azure from a cost perspective, I am choosing to run the high IO query here, and it will come back in a moment. Notice it's running, but there's no errors. Here it is in Azure SQL DB. That came back pretty quick because there's less there. Didn't have, it ran without error. It didn't bring a result set back. That might be because my workload is a little off at the moment, but it has worked for me before because I run this query frequently. I went back to make sure I put it in the right database. I've run that query frequently in Azure SQL DB in my production environment. And again, here we go. In the Azure VM, here are a bunch of high IO queries. So the intent of running those tools is, of course, to tell you about them if there are some you're not familiar with. I particularly like Michael J. Swartz stuff. I have run other things. Jonathan Cahias has some fantastic plan cache queries. I've run them against Azure SQL DB, and they work wonderfully. Well, as wonderfully as anything that parses XML can work. They run wonderfully against Azure SQL Managed Instance. They run wonderfully against VMs. So all of your techniques will work. Now, the one thing I will say is management tools, regardless of the vendor, are still catching up with some things as far as the PaaS services go. Your mileage will vary as to exactly what information you get out of your management tools. But they are all either giving you something or very close to giving you something from that perspective. So your management tools, the ones you know and love, also work and will help you with your troubleshooting. Moving back to the slides. Any questions on my quick set of demos there?
Yeah, there's a question from Ash.
Sure.
A more general question. Do you think it is more common for business to use Azure Windows Server VMs and then install SQL Server on it themselves, or to use the Azure SQL database for handling their DB needs? Or is it pretty widely split based on the different needs?
All right, I'm going to put the DBA hat on and say it depends. I would say a company that is comfortable being on at least SQL Server 2017 or 2019 current CU is probably deploying from the marketplace. I prefer to deploy from the marketplace because it then gives us a standard disk layout. There are absolutely valid reasons to do the install yourself. Whether you need to avoid a particular CU because testing has gone poorly with that CU for you, whether you need a version of SQL Server that's not in the marketplace. I mean, it's completely reasonable to say you want to deploy a 16. It's less reasonable to say you want to deploy a 14 or a 12, but maybe you have to, and you can install those manually. So I would hope businesses are going to the marketplace wherever possible, because you can script that and make that deployment much simpler, much faster. You know, automate all the things that you possibly can. It is a much longer automation process, of course, to do the install automation, but it can be done. Automate all the things so you can stop working on the boring stuff and do the fun stuff. If you're installing SQL Server all the time and managing refreshes in your test environment all the time, you don't have time to dig deeper into, I don't know, performance tuning in Azure SQL DB. Hopefully that answered your question. I'm sorry I don't have a statistical survey or anything to tell you, and hopefully my reasons for it depends made sense to you.
Yeah, Ash says, I like the answer as well, but this is something that I personally thought that Ash was asking between IaaS and PaaS.
Okay.
Or you might think he's asking between, he or she's asking between manual install or marketplace. I think it's the earlier one, but he also liked the answer you gave. I think that also gave some more insight that, that helped him out. So yeah, go ahead if you want to add more.
I'll answer the other question just to cover all our bases in case somebody else is thinking it too. I know our rule of thumb at Chipotle is if we can put it in Azure SQL DB, that's our first choice. If we can put it in Azure Managed Instance, but not Azure SQL DB, that's our second choice. And we will deploy Azure VMs where necessary. That's kind of how we do things from our perspective. What keeps us from putting things in Azure SQL DB for us are generally cross-database queries. What keeps us out of Managed Instance in one particular case is the data size. While it may be a little out of scope, I'll touch on this. Azure SQL DB has something called hyperscale, which has a much greater amount of storage that it can access. Azure SQL Managed Instance is capped at a total of 16 terabytes for the instance, which I know sounds like a lot, but I have an instance that its three biggest databases aggregated are 25 terabytes, and there are several other databases that are necessary to all move together in that same instance. So I can't take it to Azure SQL DB because of the cross query, and I can't take it to Azure Managed Instance because of the size. So that's a case where we have to keep it in a VM. As you start to look at your workloads and your caveats and your vendor support, sadly, some vendors don't support the cloud services. And when I say sadly, I'm aware off the top of my head of a Microsoft product that has all the earmarks of being a dead product walking, because it only works on Azure, or it only works on a local named instance to where the product itself is installed. The maximum supported version is SQL Server 2016, and my cloud team wants to use that product. So I have to keep that on a VM. So there's a lot of stuff that goes on there. If we hold on just a second, these last couple slides are just the links and acknowledgements. And these are mostly links to documentation from Microsoft, except for the last two links, which are a blog post on SQL performance from Tim Radney, diving a little deeper into performance tuning and query tuning on Azure SQL DB. And this last side is Michael J. Swartz links. Now we are up to the questions portion of things.
Sure. Madhu has a question.
Sure.
What are the scale out options of SQL Server to share databases on multiple nodes? Do you need a little bit more info on that? I'm not.
If you could put a little more info in, I'll start walking down a path. Will you put that additional info in? So if you're talking scale out from a read perspective, it is still in Azure VMs, it's availability groups. You can do read scale out on Azure SQL DB and Azure Managed Instance in a similar fashion, although it's not, they don't say it's an availability group. From what I understand, it is functionally a distributed availability group under the hood. So you can scale out reads. Relational databases, for the better or for the worse, don't scale out very well without a lot of work, and maybe not at all, because I'm too scared to even think about trying it to see if, because the amount of work it would take. I wouldn't scale. There's no known way to me to scale out writes. You have to scale up. Happily, particularly in the PaaS solutions, auto scaling is fairly easy to set, and you can scale up and back and scale back down for those peak times and not have to incur the cost all the time for those peaks. You know, for me, that's the 4 or 5 high burrito sales days a year.
So Madhu has a follow-up on the previous question that I read to you.
Fantastic.
It says not read scale out. Can we use Polybase?
Maybe. I am not an expert in Polybase, so I'm going to leave it at maybe. I would say first person who comes to mind as an expert in Polybase is Kevin Fiesel. So if you find his blog, he probably has some stuff. There are probably other folks who I just don't know as experts in Polybase, but I am not one, and I would not even try and fake a guess at that. Andy or Tayob, do you have any Polybase experience?
I don't have with Azure SQL database, but with on-premises, yes.
Well, and the thing is, as far as the original question is concerned, Polybase is not necessarily a replacement for SQL Server in a scale-out scenario, if I'm interpreting the question correctly. So, you know, Polybase is a different tool to solve a different challenge. So, yeah.
And I suppose if you're on SQL Server 2019 on-prem, the other thing we can throw into the mix, depending on what the challenge you're trying to solve is big data clusters. But that could be an entirely off-base answer, because that's one of those things where I know it does some scale out things, but it may not be related to anything you're trying to do.
Okay, unless there is any other follow-up we see from Madhu, I'm going to move to the next questions. There are a few came in.
All right.
One is from Cecile. What is the best way to perform maintenance tasks in Azure DB?
In Azure SQL DB, the best way to do it is the Tiger team has written a kind of a lightweight version of Ola Hallengren's maintenance solution. I would recommend that simply because of the lightweight piece of it. You want to be conscious of read-write in CPU, particularly in the PaaS solutions, so you're managing your bill effectively, because that is an important part of managing SQL in Azure. And then from a scheduling perspective, you're going to most likely use Azure Automation, which has some great advantages in that it's A, built into Azure, and B, you can store credentials easily in Key Vault, which is exactly what it sounds like. It is a credential storage utility that is part of Azure. And then the scheduling happens through Azure Automation. You could, of course, use another enterprise scheduling manager on a VM, or maybe there's a third-party PaaS solution that I don't know about, which is certainly possible. And then you would look at your workload, look at your peak times, and do all the things you do today to figure out when you're going to schedule maintenance, and schedule it that way. And you're going to look at all the things you do today in terms of parameters for defragmentation, and whether or not you're going to do full sample or not from a statistics update perspective, and you're going to look at query plans and go, hey, these are the 25 most used statistics. I'm going to make sure I tactically and surgically update those, a couple times a day, maybe, whatever makes sense for your environment. I'm going to hit the rest, once a day or once every other day as necessary.
Great. So another question from Max. Security. So question is about security. So you put a colon there. Are all databases in Azure in quote contained databases?
Azure SQL DB are contained databases, or can be configured as contained databases with contained users, and can have TDE enabled on them. I believe it's enabled by default, and I apologize, I don't know that off the top of my head. Managed instance, I think you can set contained databases. Honestly, I don't do a ton of security work. So
Can I add a comment here, Peter?
Absolutely.
Recently Microsoft released 3 more server level role that will be able to do some stuff on every database within Azure SQL Server, which is a detour from the initial plan to be everything contained. I push in my workplace to be everything contained. So if you're setting up availability group or failover groups, when you failover, you don't have to wonder about logins missing on the secondary nodes.
Excellent. And the other piece, and I know nothing about this other than it exists, is if you're talking about the PaaS services, you can look into Secure Enclave as well. Any additional questions?
I do not see any other questions or comments. So we are at 11:17. Folks, you can still put your questions, comments. Otherwise, we'll probably go for a short break, and then grab your tea, coffee, whatever you prefer. And our next session will be by David Stokes talking about indexes versus histograms, to speed up database searches. And on the other track 1 will be by Dave Wenzel. You might not need a data warehouse anymore. And so those are coming up in 12 minutes.
All right. Thank you so much, folks, for taking time out of your day to listen to my session. Teob, Andy, thank you so much for moderating the session and jumping in with some answers. And folks, remember to look into the sponsors and support them because they make conferences like this one happen. Thanks, everybody. Have a fantastic day.
All right, everyone. So I hope you guys all enjoyed that very first session. So Dave, are you there now? I'm going to get you all spun up and set up. I'll be your moderator for the next session.
Okay, I think I'm ready to go.
All right, excellent. So Dave, I am going to make you presenter now, so that way you can test and do some AV checks and all that kind of good stuff. So stand by.
Sounds good.
Yep, and if you want to, you can turn on your video or not. That's totally up to you.
Trying to, it keeps telling me host to stop the video. So.
All right, hold on for a moment. Try that now.
And